Hello, everybody. My name is Michal Jarmolkowicz. I'm very excited to be here with you today. I will be presenting our next generation credential management system. I'll talk a brief about myself, my background, and my current role. I'll introduce you to UBS and UBS technology, so you get a perspective of the scale of the things that we're doing and our challenges. And the main topic for today is CREDS, the credential management systems, and very many interesting challenges that connect with that. I'll also talk about general attacks at PKI systems and systems that heavily depend on them. And I'm sure there will be time for questions. I have many years of background providing authentication, authorization, advanced digital signature solutions for the financial sector, for the banking sector. I've been privileged to be able to work on some really amazing projects, securing millions of financial transactions around the world, making our automotive industry sleep better, making Blu-rays a bit harder to hack. But my favorites was always advanced digital signatures that help protect from failing cryptography. I finished Warsaw University of Technology when I had a chance to play with something that much later was called the cloud. I continued my education in Denmark when I had a chance to design and play with early automated intrusion detection systems. And then for more than 10 years, I've been working at IBM Crypto Competence Center. Now, from last year, I'm proud to be part of UBS and be able to drive many challenges there. I'm responsible for leading the development of our credentials management strategy, and I'm also responsible for a development team which will be providing the CREDS solution I will be talking about. So let's get started. UBS, I'm sure you heard, is a multinational financial institution with really long history. And UBS technology is a big part of it. We have many data centers around the world, each with thousands of servers, all that supporting thousands of applications that keep our business running. And this is really important to give you a scale of what challenges a credential management system has to address. So if you were to guess, what do you think, how many people do we have in technology? Like it's 20,000 people in group technology. So we're the size of Facebook in technology, which really allows us to make amazing things. And there are really great projects all around, many of them in Poland. And I'm proud to lead one of them in credentials management. So UBS invests heavily in infrastructure modernization to be efficient. Most of the initiatives are driven by the need for automation. And we keep challenging ourselves, and also the CREDS, which is the next evolution of our credential management systems, is a response to the challenge. There's no actually solution good that can address the challenges we have ahead. So we took it on ourselves to continue to lead the role. And I'm really proud of UBS being a leader in use of certificates for authentication of servers. It's been doing it for more than decades, way before there was a standard for certificates. And we started with 1,000 servers, but this number really grew exponentially every few years. And the system we have right now is simply not enough to address the challenges ahead, and needs a evolutionary change. So we're building a system that will last for the next decade and hope and allow UBS to grow much faster. We are again faced with a situation when there's really no standards among vendors for providing the solutions that we already need and we soon will depend on. So we're leading the change, hopefully seeing vendors work on, and join us in working on standards with time. So what's the challenge, really? What's the ultimate challenge? We met with our stakeholders, with our internal clients, and what we heard from them is that they need time. They need really to minimize completely the delay as much as we can. They even challenged us so much that we hit the physical barriers of how fast things can be transfers. But that's where we're heading in the future. In some places, we'll need innovative approaches to pre-generating credentials, so they're ready at the place. Some will be able to live with some delays, but still the current systems are not yet ready to provide the automation that's required by business. And the ultimate challenge, they say, is, and they dream of really, because they see they will need it very soon, is to start with a business application which is running internally, but increase the capacity, be able to increase the capacity in real time. And this might seem simple, but when you consider an institution like UBS with different zones, with different geographies, and then internal cloud, external cloud, this really becomes extremely complex. And providing a solution that can address this in real time, that's the ultimate challenge that we're facing, and that we hopefully have I think, a solution for. So this is the landscape that we have. We expect that we won't only depend on certificates for authentication. There will be different kinds of credentials, and this will continue, and maybe even new ones will be created. This will be used in ephemeral infrastructures, so this means very short-lived certificates. Also gives some opportunities, because a short-lived certificate doesn't really need a renewal, which allows to make things a bit more efficiently. And we also face the problem right now, which I mentioned, that there's really no standard solution, and all the vendors, if you look at the external cloud, they have their own approach to identity and access management, and there's no unified way between vendors to really address that. Some of them are starting to think of solutions, but they're still not there. So we're again leading the change there. What we want to achieve is a central place, central view, independent of the environment, which is extremely important, because we want to have the control where the expertise is. We don't really want those security islands, which was actually the risks which we are facing should we have stayed with the current architecture. And this is our solution. So we need to deploy credentials very late in the deployment process. We came up with an approach which allows us to actually make applications request credentials themselves and also renew them themselves. And I'll tell about the reasoning behind that and how we see this done. But it's extremely important that when we look forward, that we eliminate all possible manual steps. And after struggling to come up with a unified approach to this problem that will address those multiple environments, multiple credential types. We actually decided to go for an abstract approach, which doesn't really, so at the core there's an abstraction, and it only later maps to a given environment and what a bootstrap credential is in this environment and what is allowed and how. But at the core, it's a really beautiful design, and we're really happy with that. And what's the reasoning? Why you want to go this way? It's actually very simple. In every project, you see the expertise, the knowledge, everything that you need is there only at the deployment time. And if you look years later, for example, 2 years later, when a certificate is expired, people might have moved, might have left the company, or simply, we should observe that as well, will not accept the responsibility any longer. So you want to make the system and all the policies and the processes work in a way that everything is decided at deployment time, because it makes obvious sense if the application is allowed to operate in a given computing environment. Why shouldn't it be allowed to request a credential for itself? That's the simple philosophy behind it, and something we're doing in UBS. So to give you a brief of how this model looks like, I told you about this abstraction. So we defined an entity. It's actually a term which is funny. We also met talking with one of the vendors recently after we had this invented this internally. So I'm happy to see that people come up with the same solutions, and hopefully the work and future cooperation with vendors will lead to some standards in this space. So there's an abstraction, an entity. It might be anything. It might be an endpoint. It might be server, a database, a technical user, a map infrastructure, many different examples. And the core system doesn't really care. What it cares is a definition of a domain, and this is not necessarily in DNS terms. It might be in DNS terms, a domain defined for this subset, like DNS subset, but completely not necessarily. It might be a geographic domain. It might be an environment domain, a subdomain. So it's really a tree structure that we envision that will basically define, a given domain will define the subset of entities that can have a credential in itself. And also the domain defines the inventory which governs which entities can request a credential. So we go from like one central inventory to like a meta inventory idea. But this really allows to decouple many problems and solve them one by one, adding environment by environment without really affecting the core design. And then there's a policy connected to the given domain, which basically defines which credential type can be requested for this domain. And at the top level, it's again a tree structure. At the top level, this might be as simple as corporate standards, which are currently enforced for cryptography, for algorithms, and so on. But it can get very gradual to one entity if required. All that connected with a security manifest that captures the authentication and authorization requirements of a given domain, completes the whole model. And we're really proud of this and hope that this will also be adopted by some vendor products and maybe lead to broader discussion about the future standard. So the system which is we start to develop it right now, will provide, it will be very API-centric. There will be a user interface, but mostly for users that don't need credentials often. those will be standard use cases like a web shop, credential experience. They go, they don't really need to be experts in credentials. They just select from the web shop what they need, and this is what they get. But otherwise, we'll provide REST APIs, a lot of actually microservices that will provide different functionalities for our customers to use. APIs that don't really require an agent on the endpoint, but some of our customers actually would like to have to continue support for the agents that we have, and this will always also be possible. We found a nice way to actually decouple that and provide both. These are the technologies that we're using. It will be mostly Java, but we're also toying with some technologies I'm personally very excited about, like Activity, which gives huge transparency between development and business people. So gives us a clear way to implement all the processes, and also then later modify them without actually the need for coding. So if you feel at home with those type of technologies and you feel challenged by those kind of problems, there might be a place for you in our team. I'll share some thoughts from my experience working with different PKI solutions and some problems I saw and possible attack vectors, and also things to keep in mind when actually securing those kinds of systems. So if you would like to attack a PKI-based system, what would be your approach? What would be the first thing you think of? Most people would think of the private key, right? I want to get hold of the private key, or at least I want to be able to get hold of its usage. But there are actually much simpler ways and more effective. The private key usually enjoys a huge level of protection, which research actually shows, and also experience, which cannot be told about the trust launcher. And often it's after the private key is set up in a system, people forget about actually the proper management of and protection of the trust launcher. And it proves to be the easiest way actually to attack all kinds of PKI-based system. So keeping in mind when attacking or protecting your systems, credential management system should be constructed in a way that also manages the trust launcher, because people won't do that. After they get the private key, their application is working, they don't care. Some other possible attacks. So simple one, substitute the data to be verified. In many cases, we forget that we actually view signatures on devices which cannot be trusted. And this is a simple fact that somehow escapes in many cases. So if one by some means can trick what is being shown, and then it might be possible to really trick the system. Some other attacks that are seen in your world are tricking the system to conclude the opposite result. It's usually a bit harder, but still quite a lot of attacks happen actually this way. Other ways of attacking the systems is seems obvious. I got a hold of a key. Maybe it was reported that it was compromised already, but what if I can trick the revocation results? What if I can maybe block the delivery of the revocation response? How the system will behave? Will it continue getting no revocation information? Maybe I can trick and reply the OCSP check. So many different possible attacks here. And last but not least, the hidden code. So keep reviewing this. I had a personal experience of actually finding some nasty things in code review. And a security checklist. So are the keys secure, right? We all know that. But your takeaway, is my validation environment secure? Right? Can I be sure that the validation environment cannot be tricked? So basic things that, am I really signing what I think I'm signing with different formats of messages? This can be really tricky. There have been shown a lot of attacks when actually either the document can have double format and something different is showing when somebody is opening, and it can mean double things. Not to mention all the things that can happen to XML. I saw a great number of problems with actually keeping the signatures valid, either by storage or inclusion in some workflow systems. This is really something, especially with formats like XML, that very often is people managing the workflow systems don't know the requirements of how a XML signature should be handled, and that leads to really lot of problems. And getting to things that are my favorites is really like, do I have all the required validation data when somebody comes and I need to prove that the signature is valid? And my personal favorite is the long-term validity. Like, what happens when the key is compromised? Usually that's over without any additional protection. But there are ways to protect signatures from basically all kinds of attacks. When correctly implemented, it can even protect from the compromise of the CA, and also including the compromise of cryptographic algorithms themselves. So when you design systems, also keep in mind how long do you need to keep the signatures valid. Another takeaway. I hope you enjoyed the short presentation. I open the floor to questions. Feel free to join us later after this lecture. We have a UBS stand in the corner, and there's a challenge and some nice gifts. Thank you very much.